Yo, what's up? What's up? So, I'm very hopeful for today's stream. I think at the end of last stream, we managed to set up an approach to get the edges to look nice, independent of the underlying topology. So, we don't need to change the topology or anything like that, apart from the small changes we're going to do in this solution. And I'm going to try and explain it. Yo, what's up, Gerard? Okay, so let me just try and visualize the problem we're having and the idea of how to fix it. Fuck yeah, Derek, today we take down the jagged edges once and for all. I sure as hell hope so. Let's see, yeah, maybe let's end there. So Gerard, what are we working on? We're working on these jagged edges here. We have a pretty nice fluid simulation going. We visualize each step. Unfortunately, the visualization leaves a tiny bit to be improved here. And it's quite apparent when you take a look at the topology like this. And this is actually, let's see here. Now this is by default. So you can see that we have these issues where ground intersects with water. And we want to make these a little bit better. And it stems from the fact that this point here is so this water point is above ground, this one as well, but this one is not. And because of the topology of the meshes, we can't simply change the height of this one in such a way that we get a better intersection here. Instead, what we need to do is we need to take this water point and move it towards the points with water. So what one could do, maybe we can do that. But like when we move from this point to this point, we calculate how much water should be in this point if this one spreads. We do it the same for each point spreading to this point. Then we take the max value of that one. Then we know how much water we have at this point. What we then need to do is we need to figure out the position within this quad where that point should be, dependent on the amount of water we have. Yesterday I mentioned doing interpolation. I think linear interpolation should be okay. I wonder if it's enough that we figure out from which point of these we get the most. We can try that. So this one gets its water from this, and this point. We figure out which one of these points that give the most water. So let's say that it's this one. I wonder if that will be enough. And then we interpolate. We move this point along this line until we're above ground. But if we only do that, let's see here. If this one flows the most water, then if we interpolate towards this one, we should get above this one and this line. So we should be getting maybe it around here, and then we draw this line instead. I don't know if it's enough to just move interpolate between the point with the most water and this one. We're gonna have to figure it out. Otherwise, what you could do, this one is the most important one, I think. It should be okay to take the one with the most water. Maybe we can try it. Can you create a function to say something like if vertex distance to water is less than 1, then vertex height must be lower than water height? Yeah, so this is not a problem of understanding if a point is underwater or not. It is a problem concerning, so we have two meshes here, one ground mesh and one water mesh. The water mesh gets distorted based on water amounts, and unfortunately when these two meshes intersect, we get this artifact here, so it looked jagged, and that's just how, because of the topology. We can say here that if it's aligned with the topology, then we don't have that problem. So it's more of a problem of how we should alter the points controlling the intersection to make the intersection look good. And I think we're gonna do this purely in the shader for now. It's easy to try out. We don't need to exit and enter all the time, and we can just distort. So this vertex, for instance, we read all of its neighbors. We get the one with the most water. And then we interpolate towards that one. Gerard has, sorry, I will shut up now. No, don't. Like, I've said it multiple times during my streams, like, every input, every question, every tip is very much appreciated. Like, sometimes, even though the tip or the question doesn't help or isn't related, it makes me iterate something, maybe gives a new idea, like, so it's totally fine. Yeah, but before we can do this in the shader, we need to do one thing, and we need to feed the correct textures to the shader. We need to feed, actually, do we need the yeah, we do. So terrain procedural water, right now we have some tessellation going on in this shader, but that's okay. And then we have a terrain data texture, and we're going to do, let's call it water data texture. Oops. Okay, and then we just need to set this one as well, and we're gonna do it in terrain patch. And I just like to have my, ooh, do we not have it here? Maybe we have it in terrain data, could that be? No. Terrain data shader property name, we should, we have it here. Okay, so let's add this, and then we just need to figure out we're gonna change this one to height, this one to height. Did we have any more? Okay, that should be it. So now within the shader we should have access to both water data and terrain data. What do we do right now? Vertex shader output. For now I'm thinking about doing something like vertex shader output, and let's disable the tessellation shader for now. Maybe we will reintroduce it later. Do we use this one? Domain. And that's about it. Okay, so we should be able to play now, pour water, and then we can do some extra calculations in the water shader. I'm gonna do one more thing. Do we have a problem here? Oh yeah. View direction world space. Yeah, we removed this one, so let's do one sec. Domain shader output, view direction world space. Let's put this one back here. Okay. And the last thing before we run is we're gonna set this one to the most water, and I wonder, okay, if it's not visible water, it doesn't have already visible water and increase. So this one and this one pretty much takes out each other, but we can keep it like this. Then we set it to fluid spread, so we will always have the most amount of water we're gonna spread. So that's good. Yeah, let's keep it like this. Let's play it. Let's pour some water, and then we have, then we will show the artifacts, and then we will alter, then we will distort or displace the vertices based on the data we have, hopefully in such a way that the edges gets improved. I'm actually going to add a, let's see here. Okay, I think this is a good point. I'm actually, within the shader, I'm also gonna add a, let's see here, do we have test? No, let's go with header test properties. And let's add a displace multiplier. And by default, we just put this one at 1. This is actually we're gonna make it into a range between 0 and 1. So I'm just gonna have, now we will be having now a slider is available to us, which we can drag between 0 and 1. 0 being no displacement, 1 being maximum displacement. And this will just help with debugging, I think. So we can easily compare between the normal state and the displaced state. And we need to add this one down here. Okay, so the idea is that in the vertex shader we read a lot of neighboring data. I'm pretty okay with this because when we work on the water shader later on and we want to get the reflection, below surface distortions, movement, whatever, when we want to get all of those things in place, we're going to need the neighboring values. We're going to calculate flow and stuff like that. So first of all, we calculate position OS here. Before we take the position object space and calculate the world space, clip space, and so on. One more thing. Let's change this to SV position. Okay, so right about here, displace position in object space to hopefully, let's be realistic, to hopefully minimize intersection artifacts. Yeah. So here we want to read, I wonder if we can do float to, we want to store two values here. We want to store water surface height and ground height. So we're gonna do like this. Data values. Do we need new? I have no idea if we can do it like this, but let's see. And we want it to be 9 values. Or it's not often I work with arrays in shaders, so let's see. HLSL array. Won't we be able to, maybe we should just do it like, yo, what's up, Divine? Oh, Oh, actually, fuck, I had it. Yes. I wonder if we can do it. Can we do it like 9 data values? I want to instantiate it and then fill it up in a for loop. But maybe we can do it like this. And then we just instantiate it like a block like this. Float 2. We want to get the UVs as well. And we're going to do it like this. Terrain data UV. Yes, and then we sample this one. I wonder, do we also have mesh grid delta? Let's see. Mesh grid delta, what do we have? 0.5, that's definitely not what we want. But actually, with grid delta, grid offset, distance grid width, distance grid delta. I want basically I want I thought we had this. I want the UV delta between entry points. So that's pretty much 1 divided by number of entries. But one sec. We should have this available to us. Terrain data texture UV scale. We have them hidden. Terrain data texture UV scale, terrain data texture UV offset. I just want to make sure we're working with the correct values here. Oops. Terrain base. Resolution subdivided minus 1 divided by resolution subdivided. Not really what we want. 1 divided by resolution subdivided times 0.5. Okay, this is half what we want, I think. So let's see here. Terrain patch. Procedural water. Okay, so first of all, what I'm going to do is we're going to calculate float UV step is equal to something UV texture offset, but I think we're going to do 2 times this one. I want to do this in a for loop. HLSL instantiate array and fill it in loop. And this is what I thought we would be doing. Float two data values. Ah, I see. And let's just do what do we want to do? I times is it like this we want to do it? No, we can't do it like that. Let's just do the simple route and do one sec. I want to fill this out in a specific order as well. So yeah, we're gonna do it like this. Let's just copy transparent blur box shader. Thought we had it here. Here we just add it, but that should be okay. Okay, let's go 0 less than 3, 0, 1, 2, 0 less than 3, and then we do I minus 1, j minus 1, right? And then we do we want to do j times 3 plus I is equal to something. So let's just put it to 1 right now. So what do we have? 0 times 3, 0, then 0. Or actually we could just do it as this, I suppose, and that's way more visible as well. And then we do I, j, although I wonder about this. Let's see. So the middle point will have an index of offset by 1. So float 2, and here we read the texture value. Actually, we can calculate UV as well. So float 2 UV is equal to where do we have it? Here. Here we go. Terrain data UV, and then we sample. Let's take these two lines and put it, and we're just going to rename this one UV, and this one is going to be input.uv. Then we take this line. So UV, we calculate the UV. We calculate the UV step size, and UV neighbor is equal to UV plus, I wonder if we can do do this to make sure. What's up, Campo? Times UV step index of y times UV step. Right. Okay, so we're gonna have ground at place 1, so terrain data texture sample terrain, and here let's just do UV neighbor, and then water data texture UV neighbor. Campo Computing, are you programming a game without using an engine? No, I'm using Unity. Am I missing something here? Offset index between 0 and 2 to -1 and 1. Yeah, whatever. Don't do it like this. Yeah, let's see if we have any issues with this. Vertex declaration. Something wrong with vertex shader input data. That's interesting. 192. Yes, we also want to do this. So we want R here and we want R here. But we still have this issue, which is, or is that one an old one? I'm gonna hope it's an old one. Okay, so now we have this. Hopefully we have the correct values here. I want to see if we have the same, if we have the correct values here by doing this. We're gonna do float 3 position is, let's see here, position displaced OS is equal to lerp between position OS. In fact, we just do this. Let's call this one position OS. Let's take the one and remove this. So we lerp between input position OS XYZ and float 3. Let's do this. Inputs.position OS XYZ. So we lerp between, let's do this, and float 3 position os dot x data values 1 1 dot x position os dot z. Okay, so this is what I eventually want to do. I just want to see that the lerp works fine initially. So we're gonna do 0 here, and yeah, one more thing. We need, what did I call it? Distortion. No. Displace multiplier. Okay, so it's not really a multiplier right now, but yeah, let's do it like this. Comment this one out. Campo Computing, I got an ad, so I didn't hear the answer to the question. Okay, so your question was, are you programming a game without using an engine? And my answer is no. I'm using Unity. Let's see what we have. Displace multiply 1. Okay, so now we can displace it. We can see here. Okay, so what happens if we do, we have displacement multiply as 1, and we read the height from the data instead. Okay, so we're not entirely correct just yet. Although, yes, and that's because we read the ground instead of the water. So what we want to do is we want to put y here instead. Yes, but we have an issue. Okay, I was a little bit confused by seeing VS Code. Thanks for the answer. Yeah, I guess Godot uses a in-engine code editor, or IDE. I don't think that's possible with Unity without some form of add-on. But I like it, having it separately. I like it so much that in fact when I work in Godot, on those rare occasions, I actually still use VS Code. Unrecognized sampler to yep. Okay, so we also need to change the sampler here. So instead of terrain data texture, we want to use sampler water data texture. Okay, so now we can see that we're reading the correct values here. Not entirely sure about neighbors just yet, but can I try that real quick? Let's just assume that it's correct. So, yeah. So what I want to do here is something we can actually already calculate here. And let's do float guess we can do neighbor water max, and then I wonder if we can do initial SL get max float value. And this is not really what we want. Okay. I don't know if I want to rely but on that one though. But in this case, yeah, neighbor water max, and then we do if data values I j dot y is bigger than neighbor water max, neighbor water max is equal to data values I j dot y. So when we read in the values and put it into this matrix, we just at the same time we calculate which neighbor has the max the most water. But then again, I guess we need to do float to neighbor water max index. We could just skip this one and read, but yeah. Okay, so now we have the neighbor, or we have the max water amount of water, or max water amount. We have the neighbor index of it. And I wonder if this is enough. Maybe. So basically what we want to do, let's take a look at how it looks in the world. So in this case, we have, we have this water value and we have the index of this one. So when we're rendering this vertex or displacing it, we have access to, ooh, this might screw things up. We're gonna have to fix this, because if we have this point, we actually have access to this, and this neighbor. And we can see here that we don't actually need access to this one. Although I wonder that, I'm just gonna keep that in mind right now, that we might not want to walk in that direction. Let's add some notes here. And okay. But so the case for this one, we have reference to all the neighbors. If the calculation is done correct, which I think it is, the max is this, so we get the index of this one. So what we want to do then is we want to move this vertex towards this one, We can do it by using index and multiply. So we pretty much want to interpolate this one. We have set the height of this one already, I think. Yeah. Why am I having such a hard time seeing this? Yeah, we have. Are we still doing tessellation, by the way? Don't think we should be. There we go. Or actually, are we? Yeah, this culling going on here. Not really a big fan of it. Okay, so if we do this displacement, we do some extra culling for some reason. But let's see here. Yeah, okay, so in this case, this one has, yeah, as much water as this one. So the only thing we want to do is we want to move this one towards this one. We want to interpolate it so that the end position is at a point where this one is visible above the surface level. Although I wonder if it will fix it. So if we get it around here, maybe we can get an edge like this. So I think we want to do an inverse lerp. Or actually, do we? Yeah, we want to do an inverse lerp between this ground value and this ground value. Yeah, inverse lerp between this ground value and this ground value, and we take the water height, because then we will know between 0 and 1 at which point are we above ground level, I think. So then we want to do but first of all we want to do a check here. If data values I or 1 dot x or dot y, not dot x, is bigger than data values 1 dot y, so if the ground is higher than the water surface, that's when we want to do some extra stuff. And more specifically, we want to calculate a float new height. Well, let's name it new water height. And it's gonna be, I think, util math. We have inverse lerp here. Inverse lerp min max but then again we also need to do an additional check here. If data values y is bigger than neighbor water max, but we only want to do it for visible ones, I think. Let's try it like this first. Inverse lerp so we know that the ground of the neighbor is the biggest one, so we can do data values neighbor water max index dot x dot y or actually min I think we want to do it like this. This, and the value we want is data value, or use for the inverse lerp is y. So now we basically have a value that tells us so now we basically have a value that tells us, for this example, how far along this line do we need to walk before the water amount gets hidden by the ground. So if we use this float and then we want to lerp between the positions, so New water height, that's not really true. We're gonna call this one T. So we actually want to, we want to get this position and this position, and then we want to lerp between them. This position this position we already have. Not really though. Let's see here. Now we have that position of the ground, and then we have float3 neighbor position OS float3, and this one is what we need to do here is center position OS plus float. Nah, let's do it like this. Float3 center position os.x plus index.x multiplied by what is it called? Mesh grid delta, I think. Mesh grid delta. And for y, we just do data values neighbor water max index dot x dot y dot x and for the last part we want to do the same here, so but with the z y, something like this. So now we have center position, we have neighbor position OS. Need to rename this one, these ones a little bit later, and then we can calculate float we can just do position OS here, I think. Position OS is equal to, instead of doing this, we do we do a lerp because I still want to be able to drag this one. So we do it from position OS to lerp between center position OS, neighbor position OS, and T, I think. .270 index. That is true. Let's see. Yeah, it's this one we want to use. Here. And the problem we're seeing here is because so we definitely get to this one, but with this place multiplier being 0, we should be getting this one. So why aren't we? Or actually we are. Okay. Or okay, it works good for all points except for the ones that are outside. What the hell happened with those? It's almost like they are removed entirely. That's not good. With this one as 0, however, or this one as 0, we should be getting this one back. Why aren't we? Yeah, we can use this to alter the normals later on as well. That's gonna be nice. But let's see here. This, okay, let's see here. We enter this if the ground value is bigger than the water value, right? And we can see that that is true. So every point that is below the ground has been sort of removed. Still a little bit perplexed that we can't see the grid here, but yeah. So for every edge point, we calculate this, we don't change position OS. We calculate this, we don't change position OS. We do this, we don't change it. The only place where we change it is here. So what instead if we would be doing, if we just do this, then we get back to this, and if we do if this place multiplier is bigger than 0, then I want to do position OS is equal to Yeah, that's what I want. The fuck? Okay, so it works as it should. Are does this one screw it up so much that center position OS is equal to if we just do this one then? Yes. I hate that I can't see the grid shape for, or that the grid shape for the water is, as soon as we displace it, it's not, it doesn't really, or does it? No, it doesn't really correspond to the actual mesh. Okay, this is not what we want to do here, but instead, the fuck. Center position OS is equal to position OS X, data values 11.x, so it's a ground height, position OS Z. Is this one? It should be okay. One sec though. Now we're getting the correct. Ah, okay, I get it. Yeah, this one is this one is correct. But we want to make sure we want to make sure that float neighbor water max index bool neighbor has water false. So then we read all this. If data values neighbor water max, let's do if if data values I j dot y is bigger than data values I j dot x, neighbor has water is equal to true. Do we want to work with int here? It should be okay. So the idea is that we don't want to do this for everything. I'm still a little bit... the grid view actually confuses things more, I think. Let's do cast shadows off. Okay, beautiful. So right now we take every point in this one, and if it doesn't have water, or like if the water height isn't above ground level, we just put it or set it to ground level. That's why we get this. But we just want to do it for points that has a neighbor that has water, basically. So this one. So if neighbor has water and this is true, don't we get any change by doing that? Yo, what's up, me Pineapple? I'm also working on a creature collecting game. Mine is in Godot. Nice. Feel free to share it if you want. The neighbor has water is false. We set it to true if water is bigger than ground. This one never seems to happen. Or am I... Let's see. Night's coming along, but pretty early in, not properly announced or anything yet. So you haven't tweeted anything about it, images or anything, but yeah. I'm okay with that. Bool HLSL. True or false? Yeah, this should about do it. What am I missing? Okay, so it's not a bool data type. So this one never gets set. Why is that? Data values ij y. Would be very surprised. Okay, so if ground is higher than water for this one and any neighbor has water, what am I not seeing? Okay. Yeah, the only thing I can think about here is we're not getting the correct neighbor. Index x times UV step. UV step is 2 times terrain data texture UV offset. Let's do... these two we can hide. UV scale, UV offset 1 and 0. That explains it. Yes, okay, we need to do this. Ooh, I could have spent a lot of time on this one. So the problem we're having is terrain base, terrain material water. Let's see here. But actually we are setting these. Terrain mesh grid delta shader property. Yeah, let's just do this for now. There we go. So yeah, of course it fails because we aren't actually checking neighbors because the UV step was 0. But this time around, let's add some water. Let's quit it there. Let's see what we have. beautiful. So what we're gonna do now is this point, for instance, it's the water is not above ground level. By doing this, we set the value to it to be equal to ground level, and we get something like this, right? Is that correct? Yeah, so this one, we can take a look at this one. And we do the same for this point as well. We do it for this point, this point, this point, this point, this point, and so on and so on. So right now we just displace the height of it, and yeah, it's an ugly result. But let's see if we can distort it. So this point right here, we should be moving this one to around here. This point to around here. Yeah, let's try it. So we want to lerp between, focus it, center position OS, neighbor position OS, and we want to do it by T, I think. Nah, that's not definitely. That's definitely not what we want to do. So right now we're pretty much moving it to this point. Is that not what we want to do? We want to move this point so that it is closer to this one. I just want to see what happens if we go the other way around. That's more like it. Still fucked, though. The t we're calculating, let's see here. Inverse lerp between, well, we do inverse lerp between the ground value of this point, the ground value of the point with water, I wonder if this one screws it up for us. So we definitely want to take a neighbor that has water. Maybe. I don't know if this will fix it, but it's definitely more correct. And we're moving in the wrong direction. So what happens here? This point seems to be moving up to here. Yeah, we don't move this one at all. This one should be moved down here. This one probably gets moved up here or something. So if we have one here, we take this one, and it always seems to be center position OS. Actually, T is always 1. Let's see, am I misunderstanding something with this inverse lerp right here? We lerp between. I think one problem might be that min max, this one will always be bigger than this one, so min max, I think, at least when we're working with the final result, yes. Moving way too much here. I have no idea what's going on there. Looks I choose where to look right here, but this side definitely improves. So now to the big question, is it because something is wrong in the calculations that we don't see a fix here, or is it not sufficient to just take the max side? I hate the fact that we don't see the grid changing, and I wonder why. You are usually able to visualize it here. Let's see if someone has had the same problem. Unity mesh grid not adjusting vertex displacement. Not working on I wonder if it's because of the so if instead of this one we just do, I want to double check this, and let's remove that one, and we do position OS is equal to, okay, position OS is equal to or plus equals to float 3 0 displace multiplier 0. Here we see it. That's beautiful. But if we do here we see it as well. Fuck. And now we don't see it. So the use of this matrix, or is it this? use of sampling. Fuck it, let's do UV. So as soon as we start using texture values for this one, the Unity visualization grid doesn't follow. Why? Okay, yeah. I guess it uses, for some reason. It's gonna be extremely hard. It's gonna be extremely hard to manage to do this without a proper debug view of it. Yo, what's up, Hercules? Or am I doing something wrong? Fuck, this sucks. What do we have? Selection wire. Displace Unity displacement by texture doesn't update selection wire. I don't think this is the same problem we have. But someone... Beautiful. Can I visualize this in any other way? We can work with our own grid. Calculate grid value, mesh grid, mesh patch line. What kind of lines do we have? Yeah, I pretty much just want to add a... do we want to add a... let's do base color. Base color is equal to... so when we are when we're displacing the vertices, we're not displacing... so all of the grids we're rendering are rendered from position world space, but when we displace vertices, we don't displace UV coordinates. So if we render from using UV coordinates instead, we could do something like calculate grid value and we want to use input.uv. I think we should be having it here. Then we have distance grid delta, and here we're going to do UV offset 2.0 times this one. Then the width we want of them, let's just go with 0.01 to start. And if this one is equal to 0 or 1.0, then we do float 4, 1, 1, 1, 1, otherwise base color. Not. There we go. Okay, and if we disable selection wire, it's a little bit wrong, but let's just see if, yeah, we displace them. Okay, great. And right now we have a little bit of a problem. They are offsetted kind of in the wrong way. So they are, so we need to add input UV plus, in fact we need to work with scale here as well. Maybe we, no, we, I don't know, almost. Yeah, we need to work with scale. Let's see here, what do we do? Vertex shader input UV. Yeah, and then we don't set this one. Actually, domain, do we? Output UV is equal to input UV. Terrain data texture UV scale. Yo, what's up, Cooler SK? Yeah, at this point, you can't really expect anything else entering this channel. That's just how it's going to be. Water and what water? I've never heard that song in my life. Or maybe I have, just never thought about it. Okay, why are we getting the wrong UVs here? What am I doing wrong? Or the wrong grid, actually. We need to do something with the scale. But what? Input UV. We do set this one, right? Yeah, we do. No. And then we have something with the scale. Ah, Cooler SK, you have me all wrong. I just avoid weird links. I can search for it after the stream. What am I missing here? UV. Ah, actually, let's see here. Bam, 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 bam. What's up, Catboy King? Input UVs, these should be correct. We just want to figure out this offset here. When I think about it, let's see. Input UV times terrain texture UV scale. Terrain texture UV offset. Let's just UV. Yes, and then I think it's scaled correctly. Then we just need a offset here as well. So we're gonna do plus UV offset. Please. Yeah, that's fucking perfect. Okay, so when Unity's grid visualizer fails, we will just disable it and we will use our own. And let's pull this ground. I don't want to disable it, but we can do mesh render. Okay, what the hell is going on here? Yo, what's up, PG King? What? Okay, but this is great. Now we can definitely see what's happening with the grid here, and we can see that it's fucked. So we're doing something wrong with the calculations. Although I would like to make it even clearer. I've no idea what's going on here though. Disabling the ground render screws up what? One sec. Terrain procedural grass. We have some changes here. I want to one. Otherwise, what do we have here? There we go. Do we have anything else? Just removed a few things. We still have the weird problem. Yes, we do. Why? Okay, let's go with this one instead. We cull these as well, but we do it. Feels like a little bit weird of way of doing it. So let's do during debugging. I want I was gonna switch this one to off. Catboy King, by the way, thank you for the follow. Appreciate it. Culling is off. But what? One sec, so let's do we don't do anything weird with OS, SV position. Yeah, what the hell? I changed the wrong one. Here we want to do position. There we go. Actually, does this fix the grid problem as well? Would suck if it did. Okay. But it does when it comes to this one. Okay, so that's great. So now we can work with these instead. That's beautiful. Now the big problem is, what the hell is happening here though? So these are getting culled. Why? That's interesting. Bam. Okay. Yes. Because Position OS. Should be okay. What do we have? We have displacement at 0. So even though we enter this one, we should always choose this one. And we don't alter this one. Is it because we are... I might know. Do we have... Okay, I actually have no idea. What about the normals? Actually, is it just a case of... Are we not getting the correct neighbors? That's my first... But that shouldn't be a problem for this one. Position OS, input position OS, X, Y, Z. Are we doing something wrong here? Fluid spread. Are we getting a weird value here? No, actually, I think they should be visible from... Weren't they visible at some point? We're missing 2 triangles, 1 triangle, 1 triangle, 2 triangles. Like this. Oh. Like, it could be multiple different things, but what bothers me the most... Actually, let's do this real quick. definitely wanna show this one. Can we do we have water? No, I don't think we do. But we can see here that let's hide ground again, and let's see. So at this point we have water 93. So it's not that our water values are fucked, but something else. And if we do, yeah, if I did this, we don't have this problem. Okay. So what inside of this one screws it up? I'm still displace multiplier is 0. Oh, no, it shouldn't be that. Displace multiplier is 0, so we should be getting this value. Unless... no, we should be getting this value. Unless... okay, the issue is back. What the fuck? Okay, if I get to the bottom of this one, I need to remember what the hell is going on here. So basically, we have a property here. We can choose between 0 and 1. At 0, the only thing this one controls, I'm pretty sure, yes, the only thing this one controls is we use it as t for a lerp. Between this one and this one, if we write it like this and have it at 0 here, it doesn't work. If we hard code it to 0, it works. Oh shit, we've had a similar problem before. Why can't I seem to remember? What was the reason? Can we get an example of the implementation here? Ooh. X, Y, S. Hey, what's up, Derek? Trying to figure out how to apply your fix inside the vertex shader. No, I'm just trying to figure out why hard-coded 0 here works, but displace multiplier does not. Which is... displace multiplier 0. We have it here. We define it here. And we have it as property here. It's set to 0. So we should be getting this one, but we don't. But if we set 0 here, hard code it, then it works. Is it... yeah, for some reason, displace multiplier, wrong name, I know, doesn't work here. Why? Okay. I wonder if... X min max. Okay, there we go. Okay, so I'm thinking that the problem was we did a lerp here. We didn't clamp t between 0 and 1. So I wonder if this value became less than this one. So min, max, but this one is actually smaller and we get some form of problem. That's my only guess. Because once again, mathf unity. But we want to do lerp. The parameter t is clamped. This one does it automatically. This one does not. Not this one, but this one. So we gotta make sure. But okay. So what we're trying to do is render the ground here. We're gonna try and move this point towards this point. But as we can see, so it's this point, right? We want to move it towards here. Pretty sure. But what we do is, we actually do. But, okay, we have some problems with the height. Let me cast shadows off. Yeah, for some of these we move up too much, definitely. Okay, we're getting closer, but not entirely there just yet. We have this point. We can keep it like this right now. And okay, so this is good. We can see that this point and this point and this point, they move towards their correct places. What this one though, this one can only get water from this point, and this point. But right now we actually check this point as well, so we can see this point moving in the wrong direction. That screws it up. So we only want to check connected vertices. Wonder how we're going to do that check. I think it's okay. We're going to have to depend on the topology. We need to define it in some way. But yeah, everything else looks okay. What I'm a little bit worried about though is this one changes its, yeah, it changes its height. Definitely. Soon Cooler SK we are. Okay, so we're interpolating between them and we're changing the height as well. That's something we don't want to do. We want to keep the same height. So let's fix that issue first. Neighbor position OS. So let's do this. Displaced position OS is equal to this, but displaced position OS dot Y should still be equal to data values 1, 1 dot Y, I think. We want to displace it on X and Z, but we want to keep the Y value. We're not doing it. Look at this point. Or actually, are we? Are we? Yeah, we are. Okay, so not entirely correct. What have I missed in the calculation? The more I think about it, is it only the diagonal one we want to solve? Or change? Like, do we always want to move it by the diagonal part? Like, maybe we don't want to move points like this one. Or... Hmm. towards a neighbor we shouldn't. Okay, the algorithm is definitely not correct. Yeah, this one is rough because we're not moving along any lines. We're moving along this connection that doesn't really exist. But still. Now we pretty much always want to, we just want to take this point, put it here. Take this point, put it here. Mm-hmm. Okay, let's just try. What do we have? XZ, so it's when we move. We move in positive Z and positive X, or negative Z and negative X. Let's do. plus UV step times can we do, I'm a little bit afraid of neighbor point. Ah, fuck. Point. And then we need to fix this one as well. So what do we have? Neighborhood. I don't know. Flowing point. I missed? Oh yeah. Mm-hmm. Do we have a problem with this one? Let's see here. It's point. Unexpected token point at line 210. I don't think so. Okay. Do we have a problem with the instantiation of this one? No. What am I not seeing? We have UV. Float 2 point is equal to float 2, but we're getting a syntax error before here, right? So at line 210. So it says this line, but the fuck? What the hell am I not seeing here? Unexpected point. Is seriously HLSL point? Oops. Keywords. Yeah, get the fuck out. Okay. Okay, so now we only move the diagonal ones. That's good. Oh ho 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 ho! Look at this side. What the fuck? Going from this to this. But still. That's fucking wonderful. Yes, indeed, Derek. Here we go. Getting closer and getting closer. Do we screw up? Nah, so okay, so if we do it like this, if we look at this side, we don't change a thing. Oh my god. Look at this. Still a little bit unhappy with this one, but you know. Yeah, maybe there's just some small change in the calculations we need to do. Maybe. We still have... Yeah, we can probably improve this a bit more, but like this is a big improvement. Yo, what's up, Fabic? Perfect timing. Okay, so most of them... This one is such a big improvement on this side here. Especially this shit here. Fabric, are you moving X and Z vert position? Yes. So in the direction of the faulty topology, basically, or we're interpolating it along that line until the water becomes visible. Okay, this might be a very, very special case. Let's see here. Yeah, this point actually... I don't think this point has water. Which one is it? It's... Or maybe... Yeah, it's this one, right? Yes, this one has a height of 100 and water of 100, which means that it basically doesn't have water. Which means that... Okay, could do without that. Which means that we don't move this one. But yeah, that wouldn't change anything. Yeah, we can probably do some improvements here. Fabric, what will happen when you make new water or hole to those moved verts? Will you check if vert has been moved? We basically just do a double check in... we do all of this in the shader. So as soon as we change the data to shader, we'll have new data to work with and hopefully adjust itself. But I'm still a little bit worried about this one right here. I think we need to... we're gonna take a look at this, but this is a very nice step in the right direction. Definitely. This one, beautiful. But before we do that, we need to fix this one. So the only problem we have here is that we move in the wrong direction, right? So this one, for instance, moves here instead. UV step times float 1 UV step. Let's do it like this instead. Neighbor point Y is bigger than neighbor point X, so we check if water is bigger than... If we have visible water in this neighbor, we have neighbor has water true. If neighbor point water amount is bigger than neighbor water max, we do neighbor focus. Yeah, this one we want to fix. So neighbor focus point is equal to neighbor point. Yes. And we use this one here, but we don't use it here. Center position, neighbor water max index X. Yeah, so maybe we just want to do, let's remove focus point, neighbor water max index 0. This is not entirely true either. Oof. Modding Minecraft, when are you gonna get into the actual game? This is the actual game, man. Part of the gameplay is gonna be terraforming. Okay, I just want to do, we can clean this up quite a lot. I just want to see if we can make it work. Modding Minecraft, like the game mechanics and stuff. Also, is there going to be difficulties or levels? No levels, no difficulties. And this is game mechanics. It's like... So if we take your name, for instance, Minecraft, it's like... when Notch were programming the water in Minecraft, this is exactly what we're doing. Like, just in Minecraft you can add or remove water and it has to disperse in a certain way. That's exactly what we're doing here. This is the actual game. Part of it, at least. Yeah, so here we want to know the direction we're going. And previously what we did, we do neighbor, water max index. Yes, we're just gonna do... Can we just do... Neighbor water max index. Let's just do this for now. Float direction. I want to clean this up a lot soon. Let's do direction is equal to... In fact, this is ugly right now, but if I is equal to 0, we do direction 1, otherwise we do -1, I think. And then we can do neighbor water max index, we put this one here, and then we have direction, which we put here. Maybe something like this. It's better. I would say it's probably acceptable state. Probably. Then again, it can certainly be improved. Fabic, wait, what? This isn't a water app you're developing? One could have thunk. After watching like the last couple of months streams, one could definitely think that. Modding Minecraft, by the way, is the stream thumbnails automatically generated. It's almost like I'm afraid to say no, they're not. Derek, that is awesome, man. Amazing work. Thank you, appreciate it. Like, these edges has been bothering me for a while. And this looks good. You should see how that looks with some basic displacement. Yeah, I'm a little bit afraid of the displacement, but then again, maybe it will work. Yeah, it might. We're gonna have to take that into the account. We also need to fix the normals here. You see? But that's easy to do, I think. But first of all, this feels pretty damn good. I definitely need to fix the normals, but that should be easy. I also want to try... I'm gonna try... I want to see when it flows. I think it should be fixed when we flow as well. And I want to try one more thing as well. But let's see here. Water. What the fuck? So instead of looking like this, we have something like this. Why do we have this? Oh yeah, we still have a problem. So instead of this, we have this. But then if we go... This one is a very, 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 very special case. It's when we have points that are exactly at the same height as the water. We need to check for that one. Yeah, because right now we're implementing it under the assumption that a point that has the same amount as water as the point itself. Yeah, let's see if we can fix that. So yeah, in our check to check if something is beneath the ground, we do if the ground is bigger than water, but the water is actually under the ground when they have the same value as well. There we interpolate the normals as well. Yeah, that's what we're gonna do. So like when we calculate the normal for a point on the water, so this one for instance, then we do it using the height difference between this, and this point. And our water mesh underneath the surface, so when we have edge points, so points right at the edge of the ground, it actually looks like this. So we have, I guess we could say this point is on the edge. Might not be so in this specific case. I'm just gonna try and... But so when we calculate the normal of this one, we take this height and this height into account as well, which skews it. So basically what we want to do is, if this one isn't above ground, then we want to adjust the normal in such a way that it gets like we remove the effect these 2 points has on it. So we only want to calculate the normal from this, and this one, and this one. But let's see here. So yes, I want to check very special case. I wonder if we can do Derek genuinely gonna be one of the most visually impressive water simulations in a game once it's done. Let's hope for it. So I think the issue we have is neighbor point Y. So is the water bigger than X? This one is okay, but this one is not, because here we need to do this, I think. I don't know if this will fix it, honestly. Oh yeah, but let's see what kind of difference we get. But actually, this is not... Yeah, we're actually moving this point, but just a tiny bit. Yeah, it won't fix it. I don't know about this one. That's like the worst case scenario. I wonder how it will look when it dries up as well. The bottom line is it's still way better than it was. Are we gonna get some overflow now? Oh, we overflow. Okay. Yeah, whatever. Okay, it's very much improved. Let's take a look at how it looks. But there still exist some worst case scenarios, definitely. Some edge cases. Let's just compare it. Yeah, in this case it's not too bad. Let's take... Are those edge cases still... one sec. Yeah, the edge cases still annoys me, but I think I want to try one easy fix for it. We will take a look soon. Like, I mean, the improvement is quite huge. So instead of this, we have this. Like, there's no way around it. That's great. But do we have any worst case? I wonder, I just want to try and do terrain fluid solver. Right now we take increase water. I want to do decrease water. And then we switch increase water with decrease water. Then we set it. So that's basically, so instead of taking okay, so we get to a point which won't get enough water to be more than the ground height. So previously we took, so the neighbor with the most water amount, we spread from that neighbor. This time around we spread from the one with the least fluid surface. But it feels like, yeah, we're probably, maybe taking the average would be the best for this one. I don't know. I'm trying to think, but like the quickest way would probably be to just run it. And what do we have? Water. Yeah. Think, how does it look now actually? I want to try it earlier in the process. Do we want to take this neighbor and this neighbor as well? No. It's already what is happening, right? Maybe. I don't think we would get... Fuck, maybe we would. I don't know. Yeah, if we took all the connected neighbors into account, we could probably, instead of just interpolating it between this one, we would probably interpolate it towards here. Maybe. Wonder how hard it would be. Okay, this is how it looked previously. This is how it looks now. We still have this worst case fuck here. Fabic, how will you know if you have to interpolate in X or Z direction? So the idea would be that instead of only working with this connection, we would be working with okay, so for this point, yeah, we would be working with this and this as well. But how would that solve it? Maybe I think we can solve it in an easier way. We always want to interpolate on this one, right? Because we want to get it. We want to get as far away as we can from square shapes. We always want to interpolate on this one. The problem here is that we don't interpolate enough. Because the point so currently we calculate the t by doing inverse lerp between, we take this height, and we do inverse, and we add the water value, which gets us somewhere around here. In this worst case scenario, we happen to be right here because the water value and the ground value is the same. But if we did that, we do that, and we do it for this direction and this direction as well, we might, or not the interpolation, but the, or we do inverse interpolation between this point and this point, calculate a t. We do the same for this point and this one, calculate a t. We do the same for this one and this one and calculate a t. And then we take the biggest or smallest t, I don't remember exactly the order, and that's the t we use here. Basically, we want to move this point on this line and on this line as well. I don't know what. Yeah, it should be. I'll send you something on Discord. Let's see real quick. Can I really need to get a specific theme for this one, but let's just do this real quick. And then we do this. Ooh. Yeah, we had it on the main screen. There we go. let's see. Okay, how are you going to decide which direction to interpolate between? So this is the point we want to interpolate. It's not. Yeah, okay, so currently, if we have this point, we can only either interpolate in this direction or this direction. We just care about the diagonal right now. The question is if we would compare, like we always compare to neighbors that shows water. This point doesn't show water, and we only compare to neighbors that show water. So right now, if we take this point, we have this point and this point. Those two are candidates. This one doesn't show water, so it's no longer a candidate. This one does show water, so that's the direction we interpolate towards that point. Or we do a linear interpolation between those 2 points. The question now is if we want to fix this worst case edge case, we could either do a solution where we figure out which one of those 3 directions that will give the best result, and then we have to define the best result. I'm not entirely sure about that one just yet. Or we can interpolate them in all 3 directions. So first we do it this, then we do it this, and then we do it this. And maybe we end up here. The question is, bam. So for this one, doesn't get water from here, does get water from here. So this one would probably, it would only interpolate towards the 2 points with water. So maybe it would get to, yeah, it would probably get to around here. And then we interpolate towards this one a bit. So we would get to about here maybe. So I think instead of just interpolating towards one diagonal, we interpolate towards all the sources that has water. Does it make sense? So pretty much the direction we interpolate towards, or the points we interpolate towards, are decided by their water value. Can you interpolate the edge vertices in every direction that has water? Yeah, that's what I think we can do. So we're going to loop through. So when we get to this point, for instance, we're going to take all the neighbors. Let's make it so that we take them in this order. So we take this neighbor. Does it have water? No, it doesn't. So we leave this position as is. Then we take this neighbor. Does it have water? No, it does not. So we leave this one as is. Then we take this neighbor. Does it have water? No. So we leave this one as is. Then we take this neighbor. Does it have water? Yes. Okay, so we want to interpolate towards this one, but how do we want to interpolate towards this one? And then we use the same method as we do here. Pretty much we want to interpolate, we want to reach the intersection point. But we need to in some way, so let's say, does this one have water? Yes, we want to interpolate towards it, but we want to interpolate towards multiple points now, so maybe one sec. So let's say that we interpolate here. Then we check this neighbor, does it have water? Yes. Then we want to interpolate towards that one. So we might end up here. Then we check this one, does it have water? Yes, so we want to interpolate towards that one, and we might end up here. But hopefully the final result will be somewhere around here, I don't know. It's doable. The question is just the actual definition of the interpolation, or how we use it. Or could we just... When I look at the shape, okay, so this is what happens if we take the minimum value. Yeah, definitely don't want to do that. Terrain. Everything is doable, it's just a matter of how much time and resources you're willing to put in to make it working. True. So this point right here, this one, water 100, height 100. These are the points that screws us over right now. It doesn't have water, but it doesn't need to interpolate towards this one that far. to have visible water. Do we want a special case where x is equal to y? I don't know. But actually, if we use the same interpolation logic we use right now, we're still going to get this example, or this point right here, I think. But if we take what would happen if we take, I want to try this real quick. So we can probably do current point, why this one? Let's see. Float test is equal to sample texture LOD. What I want to move in positive X and positive Z for this one. It's this one, right? Positive X, positive Z. So we do this one. Positive X. Plus positive Z. And I also want to add positive xz. Right, yeah. And then we take these and we divide them by 3. So this is the average water of all the neighbors having water, and we use test instead of this one maybe. What kind of result do we get then? Only works in this direction, of course, but that's way too rough. So basically what I'm doing now is I'm just taking the water here, water here, water here, average them out, and that's where we want to intersect. Like when that intersection happens with the ground, that's where we want to place the vertex. But that gives a worse result, definitely. Extremely specific in this case though. Plus Z plus X. That's too much, but if we weigh it, but then again, Fabric, to be honest, this doesn't look that bad. Appreciate it, appreciate it. I don't think this is the worst case, though. I think we can get a tiny bit worse than this. So yeah, I'm probably gonna give it tomorrow as well to fix it. If we don't succeed, I'm just gonna call it like acceptable. It's in an acceptable state and we can move on to more interesting stuff. But yeah, like the difference is huge, I agree. Like this is what we had previously, this is what we have now. In certain cases we can get something like this, but... And this is only for... Oh, fuck yeah, I want to try it with a little bit of a higher... Yeah, I think it looks great as well. But thank you. I just wonder... Just put it on my tab, Fabric. I wonder if... Ah... Fuck, could we do a hard fix where we just do... that we just do... hard fix, I mean a quick fix where we just do... point current x is... let's see here, float new water height is equal to... One sec, are we actually working with... No, that's not what I want to do exactly. It's Diane Fabric, thank you so much, appreciate it. So not only do I have this result to be happy about, but also the donation. I appreciate it, man. For the awesome work you do. Thank you once again. Appreciate it. Let's see if we can make it a tiny bit more awesome. But I'm not so sure about this fix. Nah, that's not what we want to do. like we know that this specific case, it just happens when the water is almost exactly the same as the height. So if we just add a little bit of a, we basically just make sure that we need to be a certain amount of distance away from the height. It fixes this, it fixes it in this specific case. I'm just not so sure that it fixes it in, I wonder about this one though. It makes it worse here, right? No, it doesn't. Okay, so let's just try this one real quick with the flow and see how it looks. I'm not that comfortable with that type of fix though, but I think I saw yeah, still have some. Yeah, it's gonna take more than that to fix it. I just want to see the result again. Like I'm just at the edge of accepting the visuals and wanting to fix the last artifacts. What do we have here? Fuck. Am I missing something? What? How is this even possible? Oh, is this just a... This point is above, this point is above. Ah, but then again, yeah, of course. One sec, I wonder... Yeah, this worst case scenario. It's rough. It's extremely rough. Did I get it? But then again, I wonder. Terrain fluid solver, Visible water, already visible water, increase water. Then we set it to fluid spread. What do we actually do in the step before that one? Check for fluid overflow. If we can spread it, we set it. Okay, that's not true. Or that's not what we want to do. Okay, so we might not be setting the correct data. That's why it looks a little bit rougher during that phase. And if that's the case, like this I'm okay with, I think. So let's do... If this is true, we add it. Else if fluid spread no, not else if. I want to if fluid spread is bigger than n dot get value terrain water temporary, then we do n dot set value. Oh, one sec, that we already do that fix. Oh, what the hell? That's unfortunate. So if fluid spread is bigger than n get value water temporary, then we set it. Okay, this is exactly the same thing as we currently do here, I think. Because you can actually see during the spread we have some very rough cases, I would say. So what if we do... I pause. We don't really seem to fix. Fix it a tiny bit. We fix it quite a lot. Okay, with that one. Yeah, the same values. Overall, it's much better than it previously was. I'm gonna give it... Tomorrow, I'm gonna try and fix those extreme edge cases. I'm gonna give it one last try. hopefully succeed. If not, we're gonna move on because I'm growing tired of this. But yeah, one more day because now I have to run. But yeah. So as always, thank you so much for watching, everybody. Appreciate it. And thank you once again, Fabric, for the donation. Appreciate it. And hopefully I will see you all tomorrow. Have a great rest of the day. Thank you, Fabric. Peace.